So first of all, thank you everyone for one, finding this, a little difficult to get here from the main area, and two, for coming at the end of the day. I realize that I am the last thing between you and starting your evening, so I really appreciate your making it here. So GCP, GCP Next, day one. A lot of exciting stuff was announced today, and I hope you're excited to hear about a few more things and the cool things that you can build on top of Google Cloud Platform. And so with that, I'm going to jump into it. So as I said, I know it's the end of the day. I'm going to promise to keep it light, fun. There's actually even a demo at the end with a little bit of audience participation, so please stay for that. And let's get started. So my name is Morgan Hallman. I'm a product manager on the serverless team within GCP, and I can't wait to tell you about what you can build using serverless and events. And so I thanked you a number of times, one for finding it, two for coming at the end of your day, and three for attending a session that actually had a pretty nebulous title, right? Doing more with less. With less what? Well, here at Google, we care a lot about developer productivity. We really want you to be able to do the most in the shortest amount of time and add value to your users. So we want you to be able to code with less code, less infrastructure, and less work overall. And I'm going to talk to you about serverless and events and how we make that possible. And so what would be your ideal, right? If you had any system, any framework, what would be your ideal framework? It would be one that allows you to do nothing but focus on your business logic, right? To focus on user value, the things that keep users coming back to your application day in and day out, which is frankly hard enough. And things such as monitoring, configuration, service discovery, auto healing, rollback, all these complicated and thankless tasks that frankly at times take teams of people to do. They're very, very important, but they have almost nothing to do with actually running your business. So ideally, you would just focus on business logic. And software has evolved for this purpose, right? If you remember the old days of HTTPD and Apache, you had this very, very thin interface that literally just lets you receive a request and send a response. And everything in between you had to do yourself. And over time, software evolved to do a lot more of the heavy lifting for you, right? A lot of the modern frameworks do just about everything nowadays, right? They do routing, they do session management, they do caching, ORM, so you don't actually have to talk to the database. A lot of the heavy lifting has been removed when it comes to writing software. And infrastructure has been on this same trend of evolution, right? Abstracting away more and more and more such that you can focus more on adding user value, focus more on business logic. From the early days of self-hosted servers, I mean, if you've been in the industry for a while, maybe you remember the days where you had a coworker or a colleague running a $10 million business under their desk, right? I mean, it was kind of the wild, wild west, but certainly not the way to build a resilient, a reliable, a fault-tolerant business. And we then moved to managed data centers. We then moved to colos where you got more efficiency. We moved to VMs where you could pack more onto the machine itself. And then public cloud was a step function change, making it much, much easier to provision infrastructure, much, much easier to build systems. And then even on top of public cloud, right, we've added a lot of services to make things even easier on you as a developer. Things like App Engine, BigQuery, Cloud Storage, Compute Engine, Data Store, Firebase, data flow, and many other technologies. But there's still a lot of challenges, right? I mean, it's not a completely solved problem. There's complexity. Even a modest internet business these days, let's say you're doing e-commerce, a small e-commerce site, you've probably got a users database, a products database, a transactions database, you're hitting a number of different APIs. It's necessarily complex. You've got inefficient infrastructure, many of you, and that if you're running on traditional infrastructure, let's say you have nothing more than a diurnal pattern to your usage, right? Let's say you're in a single geography, a single continent. When your users are asleep and not actually hitting your service, you're still running servers, right? You're inefficient. And then these systems at times can be very difficult to extend, right? It's the corollary of the complexity point, that the more complex the system, every new feature you want to add ends up being surgery that you do to that system. And so, it's called doing more with less, serverless and events. So I'm going to say that serverless plus events helps you solve these problems. So how does it do it? So one, it's very simple. And I'm going to talk more about each one of these points. It's just code. You give us your code, we do everything else. It's fully managed. Again, we run your code, right? We take care of patching and auto scaling and everything else. You just give us your actual business logic and we do everything else. And we automatically make connections between services. So you don't need to think about APIs and handshakes and all that. It's efficient in that you pay for what you use. Again, in that diurnal example, with serverless, when your users are asleep, you're not paying. It's event-driven. So again, we only spin up compute when there's actually an event to process. And then finally, it's extensible. So the very nature of serverless encourages us to write software as microservices. And so adding a new feature, adding new functionality is as simple as just adding a new microservice to your overall application. And so now let's talk really briefly about Google's serverless event-driven framework, Cloud Functions. And yes, I'm calling it a framework, in that very much like the web and app frameworks, Cloud Functions is a framework that sits on top of Google's infrastructure, right? That lets you very simply access a number of services and just focus on writing your code. And so it's serverless. What does that mean? No server management. You don't even need to think about servers. Simple deployment model. Just give us your code. I can't say that enough times. We auto-scale it up and down, and you pay only for what you use. It's event-driven. Seems pretty simple, but let me just go through it. An event is emitted. If your function is configured to listen to that particular event, we then spin it up. Your code executes. And so what does this look like? This looks like just focusing on your business logic, right? We had all those things that needed to happen to actually get your code in a place where it could spin up and run and respond to things on that very first slide, or I guess that second slide. But this is where you're focused, just your business logic now. And Cloud Functions supports events from more than 20 Google services. So many of the most popular Google services are already integrated with Cloud Functions, and we're adding more all the time. And this is really exciting for us because each new source that we add ends up unlocking a whole new set of use cases. And you can imagine that the things you can build with, let's say, a cloud build integration or a Stackdriver logging integration are quite different from the things you might build with a Gmail integration. And so every time we open up one of these new sources, developers just amaze us and wow us with the things they build. Frankly, you guys are much more creative than we are. And to recap, why should you do it this way, the serverless and event-driven way? Again, it's simple, it's efficient, and it's extensible, easily extensible. So don't just take my word for it. That's enough of the theory. Let's look at an actual example. So in the traditional development model, I'm going to go to a situation or a scenario that many of you have probably faced. If you've done anything consumer-facing at least, you've probably faced a situation where you want to allow people to create profiles or some sort of artifact that they exist in your system. And so if you've got profiles, you probably want to have a photo associated with that profile. So the user, let's say, wants to upload a photo, and then you want to crop it and store it down for the profiles page. How would you do that in the traditional model? Well, you'd probably stand up a server and use a single server route to do everything. And so the user would upload the photo, the route would crop the image, and store it down into the profiles directory. It's not too bad. But now I want to extend that, right? I want to resize that same image, and I want to use it for my user gallery, right? I've got a number of images, let's say. I want to be able to actually have a gallery and see all the users that are there. How would we do that? Well, we just add more logic to our server route, right? So now we upload the photo, we crop the image, we store it into storage and profiles. We now resize the photo, we store it into the gallery section. Whew, that was a fair amount of work, but at least we're done. But now, let's say I want to index those profile images for searches, right? Let's say some metadata comes in. It's the user's name, right? You should be able to search via name for some profile that's on the system. So what do I do? Well, let's just add even more logic to that server route, right? So upload the image, crop it, store it in profiles, resize the image, store it in the gallery, and now take that metadata. In this case, I've shown the first name, last name, and the image URL, and let's write that into search. Is anyone starting to feel a little bit like this woman at the edge of this cliff? Very cool picture. I don't know how they took it. It looks like she's going to fall. But what's wrong with this model, right? What are some of the shortcomings? Well, it's incredibly complex, right? There's a lot going on inside that single route. It's hard to understand because so much is going on. It's hard to debug. The infrastructure is inefficient, right? We have a server in the middle to do nothing but just write things to storage. Doesn't really need to be there. We have servers running whether there's traffic or not. And then it's difficult to extend, right? Every change requires surgery to the route because we keep adding more and more. And I haven't even talked about some of the hairy distributed systems problems associated with, failures. What happens? How do we handle retries? And so, is there another way to do this? Again, the title of this talk is Serverless plus Events. So I'm going to go to Serverless Events. So yes, there's another way. But let's look at how the event-driven model helps to solve this problem. So how would we do this with Cloud Functions, Google's event-driven serverless framework? Well, let's say the user would then upload the file directly to storage, right? We don't need a server. There are no servers in this picture whatsoever. That would then cause an event to fire. It's called object.finalize. The name is unimportant, but it's basically a create event. That then causes a function to trigger, which crops the image and stores it down into profiles. No servers on this page, nothing for you as a developer to operate. Less code, less infrastructure, less work. With Cloud Functions, we really can do more with less. And so let's come back to some of those advantages I talked about, right, on that slide with the simple, efficient, extensible. Let's start with simple. So there's less boilerplate code to write. And then even in a very, very lightweight web serving framework like Flask here in Python, there's a lot of boilerplate, right? I've got to import Flask. I've got to decorate my route to tell it where to send the request. I've got to write a main function to actually run the app. There's just a lot here that has nothing to do with the business logic, right? The business logic is really just in 2 lines of code here. And for those of you who actually know something about deployment, right? If you're not just writing the backend code, but potentially deploying it as well, you know I've skipped an entire step, which is having to configure Nginx, right? Like, how do I configure my proxy? Who here believes that the way they add superior value to their users is by configuring Nginx better than the competition, right? It's somewhat rhetorical. Please, no one raise their hand. But it's true, right? It's something we all have to deal with, and it adds almost no user value. And to be clear, so you don't feel like I'm beating up on Nginx, I think it's great. It's wonderful. In fact, we here at Google package Nginx into many of our images for our runtimes. But again, it's something we should worry about, not something that you as a developer should worry about. You should just worry about your code. And let's look at what happens when we start doing this in the serverless and events way. It's just the business logic, right? Just those 2 lines of code. Google is your framework. Google is your proxy. It's also simple in the sense that it's single purpose, right? So we go from something like this, and I know it's, I've kind of loaded this slide by calling it the monolith handler. But we go from a handler that's doing a lot of different things, right? It's cropping an image, it's saving it to storage, it's resizing the image, saving it to storage, it's indexing the metadata. And again, I didn't even talk about retries and failures, right? I showed a pretty simple case. We move from that to this, where everything is single purpose, right? We're still doing all the same steps, admittedly, right? We still have to resize it, we have to crop it, we have to index things. But everything is single purpose, and it's much easier to understand, much easier to debug. And those distributed systems problems associated with failures and retries, you know who handles that? Google. We retry your code when it fails. And it's also simple in the sense that we make automatic connections between services. And so this is a point that at times can get lost, but if I want to talk from service A to service B, let's say it's cloud storage talking to a cloud function, I don't have to poll. I don't have to check, to say, did something change? Is something new? Is something new? Is something new? When most of the time the answer is no. The event is delivered directly to my serverless function. There are no APIs to contact. I don't need to figure out how to go talk to the service to go get a piece of data. I don't need to know how to go talk to a service to configure it to talk to my function. All the data that I need is delivered to my event, delivered directly to my function in most cases. And then finally, we broker those connections automatically in the sense that it literally takes about 5 seconds in the UI, maybe 2 seconds in the command line to say wire function X up to cloud storage bucket B, making it very, very simple for you to build sophisticated and powerful systems. It's also very efficient. I won't belabor this point because I think you've heard it many times. But if you have an input that looks like this, something that's kind of spiky, let's say you're a startup company and you have very few users adding profiles in the very beginning of your company's evolution. Or maybe you're very mature and people already have the profiles on their system. And let's pretend that this is not Facebook where people change their profile every single day, but a normal website where you might change it once a year. Your input could very well look like this. With Cloud Functions, your bill would track the input. With the traditional server-dominated model, when that server's up, you're paying for it. And then it's also very extensible. So let's go back to that original example, right? We were already bursting at the seams with complexity when we just had 3 steps. right? Now let's say I want to add a fourth. Let's say I want to actually extract information out of the image, right? I don't want to just take the metadata that you've provided. I want to see what's going on in the image. Maybe I want to make it a visual search. And then I want to index those attributes for even better searches. So how could I do this? Well, I could just add more logic to the server, right? I could upload the photo, crop it and save it, resize and save it, index the metadata, run it through the Vision API, and analyze the information and index those tags. But that's a lot of work. It's a lot of surgery that we have to go do. Whereas with the serverless model, the event-driven model, let's say I saved the original image and I'm triggering these 3 function flows, right? The crop and save, the resize and save, the index metadata. I've already got this, right? Adding a new piece of functionality is as simple as just adding another action to the upload event. Much, much simpler and much more extensible. No surgery required. And so a recap. It's simple, it's just code, it's fully managed, we automate all the connections. It's efficient, you pay for what you use, and it's event-driven. And finally, it's highly extensible, and that you're basically writing microservices. And so extending it is just as simple as adding a new microservice. So don't take my word for it. Let's look at how some customers are using serverless plus events to build very sophisticated systems. So the first customer we're going to talk about is Smart Parking, and they're building a real-time analytics system. A little bit of information on Smart Parking. So they've been around for over 15 years. They're in Australia, New Zealand, and the UK. They've got tens of thousands of sensors in production, and they are powered by Google Cloud Platform. Let's hear a little bit more about what they do.
The number of cars using urban roads is on the rise, putting additional strain on traffic infrastructure. Finding a safe and convenient place to park your car also adds to the frustration of planning a journey. We have a solution for this in our Smart Park system. The beauty of Smart Park lies in its simplicity and agility, allowing us to configure each site to any set of requirements. First, we survey and assess which of our technologies is most suitable to record vehicle activity. This could be automatic number plate recognition, variable message signs, car counters, in-ground or overhead sensors, or a mix of all the above. These sensing devices are designed to relay live parking events to our SmartSpot units, which provide gateways for the data and act as zones of compatibility for other services. Let me introduce you to the brains behind our system. We call it Smart Cloud, and it's a powerful and intuitive two-way communication platform that processes millions of events each day. First, Smart Cloud intakes the data from the SmartSpot gateways. It then processes each action and sends real-time information around guidance and availability to displays such as our mobile app, overhead occupancy indicators, and guidance signage.
So, I know a lot of you came in from different locales, but if your city looks anything like San Francisco, I know you're probably asking one question after seeing that video: when is this coming to my city? Very, very interesting solution. They're doing some wonderful things. So what are some of the challenges associated with building a real-time data analytics system? Well, one, you need up to the minute, sometimes even up to the second freshness. You can imagine that having stale data, if you're the operator of a parking lot or a parking garage, can be a huge problem, right? If there's an event going on, such as a ball game or a concert, being stale by even as much as 10 minutes could show a very, very different picture. Two, the data is coming from a disparate set of sources. As you saw in the video, they've got in-ground sensors, they've got overhead sensors, they've got plate readers, they've got car counters, many different sensors providing data into the system. And so as a result, what do you have to do? You've got to normalize that data, you've got to transform that data, and then finally you've got to aggregate it. So a lot of data manipulation that Smart Parking has to do. And how are they doing it? Well, with this architecture here. So this is their Smart Cloud architecture, and you can see they have a number of devices that are sending information from the different parking spots. They've got their smart spots, which do a little bit of aggregation of just the raw data. And then the backbone of this system is really Google IoT Core. It's taking in all the data and piping that into GCP through PubSub, at which point it then enters two different data flows. So one is the event flow, where the raw data is simply being piped in and saved into persistent storage. If you notice, this whole thing is serverless. There's no infrastructure to operate. And then there's the data flow, and it's almost, I shouldn't say inappropriately named, but poorly named or unfortunately named because we have a product called data flow that sits in the data flow. But try not to be confused. Bottom line, what it's doing there is it's running through a number of different analytic systems. So BigQuery, CloudML, Data Lab, Vision, Data Lab, CloudML. And it's analyzing the data, adding insights to the data, and then also saving it into persistent storage. At that point, there are APIs that digest the data and send that data to different clients. You've got dashboards, so this is the the parking garage operator. They can see real time what's going on. Payments, so if you're making a payment, keeping that data accurate. Signage, so you know how many spots are available or free in a particular area. Our favorite, enforcement here, yes, they are helping folks know when you have overstayed your welcome in a particular parking spot. And then finally, there's a metrics pipeline for folks internal in the company to understand how the network is performing and perhaps even troubleshoot some issues. So all of this done without operating any infrastructure. And don't take my word for it. Listen to their CTO. In fact, he's here at GCP Next. You'll recognize him from that wonderful beard that he's got. If you see him, tell him I said hi. But just listen to the efficiency and the productivity that he has gotten out of operating a serverless, event-driven infrastructure. They were able to completely re-architect their platform, something that took them 12 years to build in less than 18 months using serverless. That allowed them to then expand their business globally. Also, Cloud Functions, our serverless event-driven framework, was the foundation for their smart cloud data intelligence platform. And it provides their customers with instant, to-the-second accurate data intelligence and scale for millions of transactions each day. So very sophisticated, very powerful system operating absolutely no infrastructure. So let's switch gears a little bit. This is the last customer example I have, but to something that's completely different, to building a mobile application. So I want to tell you about how development firm Posse used serverless and events to build the Hamilton app. Let's hear a little bit more about that.
Hamilton is one of the most talked about and best loved musicals, with shows on Broadway, in London, and around the country. We wanted something to make the show more accessible for our fans, so we wanted to develop an app to meet the needs of fans as we started to expand the brand. We turned to Posse, a New York-based development firm, to help us develop the Hamilton app.
Hamilton's Flutter app launched in the App Store and the Play Store 3 months after we wrote our first line of code. And we accomplished a ton. Fans can enter a daily lottery for a shot at $10 tickets, buy merchandise through an e-commerce experience, take selfie photos with the Ham Cam, and get daily news and updates.
So very cool. Hamilton is doing exceptionally well on Broadway, and it's pretty exciting that they've built their app on our infrastructure. So it's completely built on serverless plus events. It's got a number of pieces of functionality. They've got a lottery, and we're going to talk a little bit more about that later. They've got karaoke, trivia, the Ham Cam, the selfie app, and you can buy merchandise from within the app as well. So let's talk about the lottery. So for those of you who aren't familiar, the lottery, Hamilton's extraordinarily popular. The lottery is an opportunity to not pay the entry price, which I believe is around $200, but the reality is that these things sell out, so it's probably more like $800 or $1,000. But instead pay $10 to enter a lottery and win a chance at tickets. And these are great tickets, I think maybe 40 or so per show. You sign up for the lottery 2 days beforehand. A day beforehand, the drawing happens, and you're either selected as a winner or you're told to enter the lottery on a subsequent day. And it's really interesting. I love making developers' lives better, and I love making you more productive. But I also love, and I hate to use the trite line, in fact, I won't use the trite line, making the world a better place, but we're making the world a better place in the sense that the creators of Hamilton with this lottery have allowed a whole new demographic to actually access Hamilton. And it's interesting because they're all about flipping models on their head. The whole play itself is about, it's a majority-minority cast, portraying the life and times of Alexander Hamilton. And this lottery, as I said, kind of does the same thing for the demographics of the audiences. So how they're doing that. So a user says, I want to be part of the lottery, enter me. That request then gets written to the real-time database, which is the backing store for all of the Hamilton app. It then triggers a Cloud Function, which first goes through Firebase auth to say that this is a legitimate request. That function then registers the fact that the user has chosen to enter the particular lottery. There's a cron job that then operates down here on a daily basis, triggering a cloud function that says who's won on that particular day. It selects the winners, writes it back into the real-time database, and also notifies Lucky Seat that these people have won, print their tickets, and the users are told of their winning status or to enter the lottery the next day. Really interesting feature. Next feature, the HamCam, the selfie app. So this is a pretty simple feature, but again, it's completely serverless, completely event-driven. Users basically take a photo, take a selfie in the app. It then writes directly to cloud storage. This is actually a lot like our theoretical example that we went through, mediated by Firebase Auth, just to make sure that this is a legitimate request. That then kicks off a cloud function, which crops and resizes the image, then writes that image URL back to the real-time database so that the user now sees their wonderful selfie in the app. And Posse told us that we made it so easy for them with the real-time database, with cloud functions, with cloud storage, to build this feature that instead of operating infrastructure, they could spend much more time on just making it fun, making it interesting, and adding effects like this to the app. And then finally, last example I'll show you from Hamilton is merchandising, right? Just buying merchandise in the store. So the user says, I want to buy something. That then kicks off two different cloud functions. The first contacts the Magento API, which is an API for managing e-commerce stores, things like SKU management, pricing, inventory management, all done via cloud functions. The next function then contacts Stripe to make payments. And this is a really interesting application, kind of a perfect application of serverless in a sense, and that Stripe doesn't trust mobile clients, doesn't trust desktop clients to make transactions. So it requires you to have a private API key that sits on a server. So if you're a very large site that does tons and tons of transactions per day, maybe this is a non-issue. But if you're an app like Hamilton, where most of it's about consuming content and not really about buying merchandise, then having that infrastructure, operating that infrastructure is quite the burden. Cloud Functions allows you to do that server key without operating any infrastructure whatsoever. So a perfect application of serverless. All right, so those are just a couple examples of what customers are doing with serverless, with events, to build very sophisticated systems. And now I want to show you something that we can build very simply using serverless and events. So we're going to come back to that example I showed earlier, the gallery app. So we have a gallery. It is backed by Cloud Firestore. That just went beta today. Hopefully you all saw that. It's an infinitely scalable NoSQL database. And what we're going to do is we're going to upload a photo. It's going to hit Twilio. We're then going to save that down to storage into the profiles. We're then going to index the data, basically take the name that was entered in and the image URL, put that in the Cloud Firestore, which will update our gallery. And then that'll kick off another function that then analyzes the image, pulls out and extracts the visual information via the Vision API, writes it back into Cloud Firestore. Sorry, my pointer is dying, and then updates the gallery in real time. And so, with that, let's switch to the demo, please. All right, so here's our gallery app. And you can see, in the interest of making it easy to understand what's going on, you can see I have both the name of the person who's uploaded something and the tags on it. So we can search here. It's a visual search engine. So Connor put a dog in, so we'll see that image. We can search on things in the image content itself, like sky, mountain, oops, if I could spell, lake. So you see we have a visual search engine right here. I'm giving Google search a run for its money. Funny enough, this actually doesn't look that different from the original version of Google. So anyway, let's now add an image to this gallery. So I'm going to upload. I'm going to walk you through what's going on behind the scenes, but I'm going to upload an image, actually of my daughter. So I'm going to upload that. Oops. Okay. Let's see. Hopefully connectivity is good enough here that goes through. And so I'm going to show you one. It's completely serverless. So I got Firestore running right here. That's our backing store. I've got a number of functions. So this is the SMS function that talks to Twilio. This is the function that then writes the data into storage. This is the function that takes that data in storage and extracts the tags, writes it into Firestore. And this is the function that adds vision tags to our app. I'm going to just show you very quickly how that flows through our system. All right, so we can see the very first function. So, name is Edie, that's my daughter's name. And the image was sent there. Next step, let's see if that completed. This is saving it down to storage. Yep, success. Next step, writing to Firestore. Wow, a lot of stuff there. Okay, success, wrote there. And then final step is actually running the Vision API. And we can see all the tags that come through. So person, facial, smile, child, girl, emotion, sitting, standing, fun, laughter, all added as tags to our image. And now if I look, oh, whoa, I've got 2 copies there of my daughter. I hope that's not a demo bug, but rather the fact that I uploaded it twice. Who knows? So now I can search on that. Search on girl, that shows up as well. So that's our app. And so can we switch back to the presentation really quickly? And so now I'm going to do something potentially risky. Audience participation. Now it's your turn. So text an image with a name, all in the same text. It can be a picture of you. It could be a picture of your kid. I put mine up there, your dog, or anything. It could be a flower. But text me an image. As I said, it's a little dangerous. And put it in our gallery. I'm trusting you. Okay, let's see what we have. So, sky. Do we have any new sky? Ooh, we've got a lot of stuff now. All right, some new images here. All right, we've got tomatoes. This is cool. Oh, no, let's see. Let's do child. I imagine we'll... Look at that. Look at all those kids. Cute kids. And I don't know why we have 2 of my daughter. Not sure. Let me just put in kid. Okay, nothing in kid. Boy, how about that? Wow, man. All right. How about fun? All right, okay. Kids are having fun. Car. Look at that. Some cool images. So I don't know if you noticed, but as I said, I trusted you folks. But I didn't show it in the code, but I've also got Safe Search running. And so, Dan, I made a mistake in trusting you, apparently. To be clear, I tuned this actually. I decided to be very conservative because I knew someone would upload something. So it's actually very possible this is just a picture of a family vacation and Dan has his shirt off. Very, very possible it's totally innocuous. Linus, same thing. This one, I had to clean the word here, so not sure that's so innocuous. But anyway, you can see that we've built a pretty sophisticated system, and I'm operating 0 infrastructure here. It's all being done via serverless, via events. Can we jump back to the presentation, please? All right. And so with that, I wanted to recap. Serverless plus events increases developer productivity. You can build more powerful systems with less code, less infrastructure, and less work. It's simpler, it's more efficient, and allows you to build more extensible systems. There are a ton of event sources available on GCP to trigger our serverless framework cloud functions, and we're adding more all the time. Customers are using it, and they're building real systems. They're building powerful systems using serverless and events, and frankly, you can too. And so here are a few other serverless talks. A couple of these have actually already happened. There are a few tomorrow as well. If you're really interested in serverless, please go to those. And with that, that's it. Again, thank you so much. I really appreciate your coming for this talk, especially at the end of the day. Now go forth and enjoy your evenings.